I am Anil Kumar. Welcome to my series on matter. We are discussing what are pure substances and what are mixtures. In this video, I'll share with you solution of a question which we posted earlier. Here is the solution of our question on classification of matter. We have taken up examples which are very confusing and always students are looking forward for correct answers. We need to classify the given items, which are diamond, oxygen, air, ash, pure water and seawater, concrete, brass, and ozone, into the categories as pure substances or mixtures. We can get into more details and classify them as in the pure substances, they could be elements or molecules. In mixtures, we can write them as homogeneous mixtures or heterogeneous mixtures. Let us try to understand why it is classified in the manner it should be, and that will be done by basic definition and notes on pure substances. What are pure substances, right? So these are the salient features for pure substances, and also here are the notes on mixtures. If you go through them, you can easily understand why any particular item is classified as a pure substance or a mixture, right? So let's begin with our question with all these elements. The very first one here is diamond. What do you think diamond is? Now, diamond is a form of carbon, surprisingly. The arrangement of these carbon atoms under very high pressure and temperature is such that it forms diamonds. They have a fixed atomic structure. So, diamond is actually a pure substance. And further, we could classify this as element. So, basically, the structure of carbon itself, it is carbon element itself and is found in nature also. So that is a pure substance. Now let's get to oxygen. What do you think? Oxygen, we're talking about, let's say, oxygen cylinder, right? So in which we have pure oxygen gas. So oxygen again is a pure substance. Now it could be atom or molecule. What do you think? Oxygen atoms are very reactive and therefore they combine together, right? And we normally see O2, so it is a molecule. So the basic form of stable oxygen is a molecule of oxygen. It's a pure substance in molecular form. You get the idea, right? Now, let's talk about air. So, can you tell me what is air? Should we classify this as a pure substance or a mixture? Well, let's look into air. As shown here, air may have nitrogen, oxygen, argon, carbon dioxide, and other things in small traces. So basically, as you can see here, air is a mixture of gases. Now, it could have some suspended particles. Now, these suspended particles could be of dust depending on which sample of air are you picking up. So, air definitely is a mixture with some suspended particles. Sometimes these could be dust particles, right? Or any other, right? So, depending on from where you pick the air, it could be classified into heterogeneous or homogeneous, but generally heterogeneous, as the air may contain, let's say, smoke, right, or something else, pollution, which makes it heterogeneous mixture, right? So, samples of air taken from different places will have different composition of impurities in it, and that makes it heterogeneous. Now, let's talk about the next item in the list, which is ash. Ash is something which remains after burning. So, we normally say ash is non aqueous and non gaseous residue after complete combustion. So, that means that if we have some material, let's say, right, and we burn it, right, burn, then what remains, black dust which remains, is the ash. So normally the ash will be treated as a mixture. So burning of anything will actually break down the organic material, and that material may also have some other impurities in it, right? Those also burn and mix with the ash. There could be some metal elements. So that makes it a mixture. Perfect. Next one here is water. Now I've mentioned two types of waters here. One is pure water, as the name suggests. It should be pure, right? And seawater. Now, seawater clearly is a mixture, and pure water is a pure substance. Now, water, when we say pure water, has molecules of hydrogen and oxygen. So, two atoms of hydrogen combined with one atom of oxygen, forming a molecule of water. Since this ratio is fixed and in the water it is uniformly distributed, it is a pure substance, right, of the form of a molecule. The sea water is a mixture where we'll have water plus many salts and minerals. So that becomes heterogeneous mixture. Now let's talk about the next topic, which is example. So what I've done here is left these three for you to decide: concrete, brass, and ozone. Concrete is a mixture of cement, sand, water, and stone. Use it for building, right? For construction. So as you can see, these things actually can be mixed very uniformly also. So we can attain a homogeneous mixture of concrete. For stability of a structure and for a strength of the structure, homogeneous structure, a homogeneous mixture of concrete is kind of a necessity. right? Well, if these things are not really mixed together uniformly, then you could also have heterogeneous mixture. But when we say concrete, we'll assume this to be homogeneous in nature. Now, brass, which is an alloy of copper and zinc, what do you think this is? Well, truly speaking, in brass, it has properties of both copper and zinc, right? So, both properties. And the ratio is not fixed. Ratio is not fixed. Well, we could have normally 67% copper, 33% zinc, right? Normally it is approximately. But close by, you understand? You could, but it varies. Plus, more than that, when you add copper and zinc, it doesn't form a new substance like copper zinc compound. You get the whole idea. And the substance formed, which is brass, has properties of both. Therefore, this is a mixture which is homogeneous in nature. Homogeneous mixtures are also called solutions, right? It is a very good example of solid solution, correct? So when you talk about mixture, solid solution, then liquid solution we have already done, and which is in the form of lemonade, for example, tea or coffee are liquid solutions. Solid solution could be brass. Air also, if you are taking from above some height, maybe kind of a pure air, right? It could be treated as a solution. Only air which is very close to cities and nearby areas will be treated as a heterogeneous mixture since it will have dust and other impurities. Now let's talk about the last thing, which is ozone. Ozone is formed with three oxygen atoms. So it's a molecule, it's a pure substance. The bonds between the oxygen, when ozone is formed, they are quite strong and they do retain. So, at a particular temperature and pressure, when we have ozone as such, it is a pure substance. Right? However, at higher temperatures or when ozone splits, in that case, it will be treated as a mixture. Right? But since we are maintaining ozone as such, like oxygen in oxygen cylinder, ozone will be treated as a pure substance, right? So, with that, we have classified all these items 1, 2, 3, 4, 5, 6, 7, 8 of them into pure substances and mixtures. And see, still, there are few ambiguities. Many times we considered, for example, ozone to be like oxygen cylinder, ozone cylinder. You get the whole idea, right? Similarly, we have cases where ash, if you have ash of a pure substance, it will not be a mixture. It will be a pure substance, right? So there are places which need more clarification. Air can be treated as a gaseous solution, correct? Where the gases are being mixed up as a mixture, but they are quite homogeneous in nature. If you take the sample of air from more than, let's say, 100 feet, then it is a homogeneous mixture. So there are conditions sometimes applied which can change between calling an item as a homogeneous mixture or heterogeneous mixture, right? Now here's a question for you. I need you to tell me, give me an example of something which is homogeneous mixture. Okay, let's call homogeneous. Okay. Give me an example for something which is a pure substance, gets converted to a mixture, heterogeneous. Okay. So you can write this in your comments. Example of a pure substance which can be converted to heterogeneous mixture without adding anything to it, right? Without adding anything. Is that clear? Perfect. So that is an exercise for you. Give me an example of a pure substance which can be converted to heterogeneous mixture without adding, right? For example, if I take water, we are not adding anything to it, right? We are not putting stones in it to make it heterogeneous mixture. Okay, you get the whole idea. So that is an exercise for you to do. I hope you have understood the concepts. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.